Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here and our fourth lesson on arithmetic series. Just to remind you of what we've done previously, we know how to work out the nth term of an arithmetic sequence or series, here a plus n subtract 1 multiplied by d, and we also know how to work out the sum of the first n terms of an arithmetic series, given by this formula here, Sn is equal to n over 2 multiplied by 2a plus n subtract 1 multiplied by d, where a is the first term and d is the common difference. So we've done lots of practice using these formulae. We're going to continue with this in slightly harder questions. So here's the first one. Pause and have a go. So here we're asked if the sum Sn of the first n terms of this series is equal to 84, find the value of n. Well, what have we got in this series? We've got that the first term is equal to negative 4 and the common difference is 2 because these terms are going up by 2 each time. So therefore, Sn, the formula for the sum of the first n terms of this arithmetic series, is given by the formula n over 2 multiplied by 2a plus n subtract 1 multiplied by d. So let's substitute in a is negative 4 and d is positive 2. Sn is therefore n over 2. 2 multiplied by negative 4, add 2 lots of n subtract 1. And let's just tidy this up a little bit for ourselves here. This is n over 2, negative 8 plus 2n subtract 2. And continuing the tidying up process, this is going to be 2n subtract 10. And I can even factor a common factor of 2 out here. And that 2 will cancel with that 2, and I get myself that this is n subtract 5. So the sum of the first n terms is equal to n multiplied by n subtract 5. But I know that the sum of the first n terms is actually got a value of 84. So I can say that Sn must equal 84, i.e. n bracket n subtract 5 is equal to 84. Let's try and solve this. So to solve this, I'm going to create a quadratic. So this is n squared subtract 5n is equal to 84. To solve a quadratic, make one side equal 0 and see if you can factorize. So this is n squared subtract 5n subtract 84 is equal to 0. I can factorize this as n subtract 12, n add 7. And therefore I get n subtract 12 is 0 or n add 7 is 0. This gives me n is 12 or n is negative 7. Now, n can't be a negative number in this case. It doesn't make any sense because you only have a positive number of terms. So we're going to ignore this one and we're going to take the value n is 12 as our answer. So therefore, we're asked to find the value of n, state at the end very clearly that n is equal to 12 and we're done. Next question, pause and have a go. So we're told if the fourth term of an arithmetic series is 14 and the sum of the first 8 terms is 128, find the sum of the first 100 terms. So there's a lot going on here. Let's start with fact 1. The fourth term of an arithmetic series is 14. So it's telling us something about T4. And we know that T4, if the nth term is a plus n subtract 1 multiplied by d, remember. So the fourth term will be a add 3d. And we're told that has value 14. Our next fact is we're told the sum of the first 8 terms is 128. So we're told something about S8. And S8, remember Sn is going to be n over 2, 2a plus n subtract 1 multiplied by d. Remember that. So S8 is going to be 8 over 2, 2a plus n subtract 1 will be 7d. And 8 over 2 is 4, so this is 4, 2a add 7d. And we're told in the question that S8 is equal to 128. We're told that S8 equals 128. So what we can do is we can make this equal to 128. 4, 2a add 7d must be equal to 128. And just to tidy things up, if you divide both sides by 4, 120, you might know, divided by 4 is 30. So 128 divided by 4, well, that would be 32. So let's think what we've got here. Let's take a pause for a second. We've got an equation up here with a and d. We've got another equation here with a and d as well. So we've got two equations in two unknowns, and that means we can find a and d from these. Now, just before we get going, how might we do this? Well, I'm going to multiply this whole equation by 2, both sides, and get 2a add 6d is equal to 28. I'm going to call that equation 1. And from here, I'm going to just write this equation here as 2a add 7d is equal to 32 and call that equation 2. And the reason I multiplied this by 2 is I wanted the coefficient of a's to be the same. They've both now got 2a in them. So if I do equation 2 subtract equation 1, 2a take away 2a is no a's, 7d take away 6d is 1d, 32 take away 28 is 4. And we get immediately that d is 4, and then we can find a by sub d is 4 into this here, a plus 3d equals 14. So this would be a plus 3 multiplied by 4 is equal to 14. A plus 12 is equal to 14. A is therefore 14 subtract 12, which is 2. So I found myself D and I found myself A. Now, all very well and good. However, we were asked to find the sum of the first 100 terms. So let's go back to our Sn over here and see if we can tidy this up. It's n over 2, 2a, we found a is 2, so 2 lots of 2, plus n subtract 1 multiplied by d, well d is 4, so that's 4 multiplied by n subtract 1. That's n over 2, 4 add 4n take away 4, and that's n over 2, and that's just going to be 4n, and that just simplifies there. There's a common factor of 2 that cancels, so n multiplied by 2n is 2n squared. So the sum of the first n terms is 2n squared, and we were asked for the sum of the first 100, so that's going to be 2 multiplied by 100 squared. 100 squared is 10,000, 2 multiplied by 10,000 is 20,000, and we're done. Next question, pause the video and have a go. So in an arithmetic series, the sum of the first 6 terms S6 is 54. Also, the third term is 2/3 the value of the fifth term, and we're asked to find the sum of the first 100 terms. So again, a lot going on here. We just have to be clear and do things in small steps. So let's just think what stuff we're going to deal with. We've got some information about the third term and the fifth term. Now we know that the nth term of an arithmetic series is a plus n subtract 1 multiplied by d. We also know the sum up to n terms is n over 2 to a plus n subtract 1 multiplied by d. So let's write the third term out. T3, the third term, is given by the expression a plus 2d. The fifth term, T5, is given by the expression a plus 4d. And we're told that the third term is 2/3 the value of the fifth term. So from this, we can say that the third term, a plus 2d, is 2/3 of the value of the fifth term, a plus 4d. And we can try and tidy this up and see if we can make this slightly neater. So multiply both sides by 3 to eliminate that 3 here, and we would get 3a plus 2d is equal to 2a plus 4d, multiplying both sides by 3. And expanding both brackets out, I get 3a plus 6d is equal to 2a plus 8d. Subtracting 2a off both sides, I get a plus 6d is equal to 8d. And subtracting the 6d off both sides, a is therefore 2d. And that's really helpful to us. We've got that a is equal to 2d. That's a nice, easy relationship there. Is there anything else I haven't used from the question? Well, yes, there is. I was also told the sum of the first 6 terms is 54. So S6, substituting in 6 in here, would be 6 over 2, 2a plus 5d. 6 over 2 is obviously 3, so that's 3, 2a plus 5d, like that. And we're told this is equal to 54. So because S6 is equal to 54, I can therefore say that 3, 2a plus 5d is equal to 54. Now I can divide both sides by this 3. 54 divided by 3. 3 goes into 5 once, remainder 2. 3 goes into 24 8 times. So dividing both sides by 3, I get 2a plus 5d is equal to 18. Now, we have a formula there and a formula there. Both have a and d in it, 2 unknowns, and we've got 2 different equations. So we can use these to find a and d. So let's substitute 1 into 2. Wherever we see a, replace it with 2d. So I've got 2 brackets 2d, add 5d is equal to 18. That's 4d, add 5d is equal to 18. That would give me 9d is equal to 18. And dividing both sides by 9, d is 2. Because I know d is 2, then a is 2 times 2. A is therefore 2 times 2, which is 4. So what have I got here? I'm just going to do carve out some space so I can do some working here. So I have found myself that A is equal to 4 and D is equal to 2. So going back to what Sn is n over 2, 2a, which is 2 multiplied by 4, plus d multiplied by n subtract 1, so 2 multiplied by n subtract 1. 2 multiplied by 4 is 8. Expanding this bracket, I get 2n subtract 2, and that's n over 2, 2n add 6. And I can tidy that up even a bit more by factoring out the 2, which cancels with that divide by 2. And I get that the sum of the first n terms is n multiplied by n add 3. Now, I wasn't asked for the sum of the first n terms. I was asked for the sum of the first 100 terms. So substituting in 100 here, I get 100 multiplied by 103, which gives me 10,300. And we have done this question. Last question, pause the video and have a go. So here we're told the sum of the first 48 terms of an arithmetic series is 4 times the sum of the first 36 terms of the same series. Find the sum of the first 30 terms of this series. So again, a lot going on here. Let's just state things that might be useful to us. It may be useful to know the nth term, which is a plus n subtract 1 multiplied by d. It's certainly going to be important to find the sum of n terms, which is given by the formula n over 2, 2a plus n subtract 1 multiplied by d. And let's see if we can use the facts given in the question. So we're told the sum of the first 48 terms, i.e. S48. So S48, we're going to substitute 48 in here. We've got 48 over 2, 2a plus 47d. And 48 over 2 is 24. So we've got 24 brackets 2a add 47d. Now we're also going to have to use some fact about the sum of the first 36 terms. So let's go off and work out S36 while we're at it. That's going to be 36 over 2, 2a plus 35d. And 36 over 2 is equal to 18. So this is 18 multiplied by 2a add 35d. So that's S36. Now, in the question, all we were told is the sum of the first 48 terms is 4 times the sum of the first 36 terms, i.e. the sum of the first 48 terms, S48, is 4 lots of S subscript 36. So using the expressions we've got here, we can say that 24 2a add 47d is going to be equal to 4 lots of this. So 4 lots of 18 bracket 2a plus 35d. Now, the numbers involved are quite large here, and it's getting quite complicated. But if you had left it in this form, you could divide both sides by 4, and you would get the following. So you would get yourself 6 bracket 2a add 47d is equal to 18 2a bracket 2a plus 35d. And then you could think to yourself, well, what if I divide both sides by 6? And if you did that, you get yourself 2a add 47d is equal to 3 bracket 2a add 35d. Now, that's dead useful because I could have expanded out and got massive numbers, but just by pausing and seeing what I could cancel first, the numbers are much smaller. So expand out the right-hand side, 2a add 47d is going to be equal to 6a add, well, 3 30s is 90, 3 5s is 15, 90 add 15 is 105d here. Now, I'm still not done, unfortunately. I've still got a lot of work to do here. I have that at the moment 2a add 47d is equal to 6a add 105d. Let's subtract 2a off both sides. I get 47d is equal to 4a add 105d. And let's subtract 105d off both sides. And I get that 4a is therefore 47d take away 105d, which is equal to negative 58d. So dividing both sides by 2 here, I get that 2a is therefore equal to negative 29d. And that could be really useful to us. It's a nice easy formula connecting a and d. I'm going to call it equation 1. Now, sometimes with these questions, you don't know where you're always going with this. You're just using the facts you're given and see if in the end it all comes out okay in the wash. What were we asked for in this question? Let's just take a second to remind ourselves. We were asked for the first 30 terms, i.e. S30. And S30, putting n is 30 into this formula, is going to be 30 divided by 2, which is 15, 2a plus 29d. And I'm going to label this 2 here. Now, something really useful has happened here, because if you know, in equation 1 I've got 2a is equal to negative 29d. And in the second expression here, what I've got is I've got a 2a. I can replace this or substitute instead of this 2a negative 29d, and I'll be able to work out S30 in just terms of d, which is a lot better than in terms of a and d. So if I substitute 1 in 2, what do I get? Well, I get that S30, the thing I'm trying to find, is equal to 15. Instead of 2a, write negative 29d, but then add 29d. And negative 29d add positive 29d is 0. And 0 times 15 is 0 again. So S30, after all that work, the d just disappears, and I get that the sum of the first 30 terms is actually 0. And we're done. And that's it for this particular question. Thanks for watching.